This is day 45 of teaching data analytics. Today we are going to understand the concept of correlation. I'm going to take the case of sales of ice cream and the temperature of each day to explain this. You will notice if you plot the sales of the ice cream on x-axis and the temperature on y-axis, you will notice a linear relationship, right? Now, this does not mean that one necessarily causes the other. Increase in temperature does not mean the sales of the ice cream will also rise. And obviously, the increase in sales of ice cream does not mean the temperature will also rise, right? Now, the correlation coefficient is calculated between -1 and 1. 1 represents a very strong correlation, -1 represents a very strong negative correlation, and 0 obviously represents no correlation, right? We're going to take the example of a different data. We're going to take the case of housing price market. This right here is price. We have a bunch of numerical variables that could be affecting this price. As a data analyst, you will have to take a call on dropping some of these columns. Now, why you have to drop these columns is because I don't believe they will hold a significant relationship with our data, right? The price is not going to be dependent on this ID or probably this date, right? So I'm just going to go ahead and drop these columns. I'm going to use the in place functionality to make sure that it sticks. I've written plt.figure. I'm giving it a fixed size because I want the figure to be clean, right? I'm going to write sns.heatmap. I'm going to write df.corr. I'm going to close in the parenthesis, and that's it. I will get my heat map, right? Now you will notice that this heat map does not have any values right now. For getting the values, you will have to write ANNOT and you're going to write equals to true, annotation equals to true. And you will get the correlation variable between two different factors, right?